Okay, so, yeah, when we have subsets, we're talking about every element of A is also an element of B, and that's our symbol. Now, yeah, those are pretty clear cut. A is a subset of B, C is a subset of B also, but C is not a subset of A because, yeah, you've got that extra element there that A doesn't have. All right, now, but there are some things you might have a little trouble with, or we need to think about a little bit. What if I went this? A is a subset of A. Based on the definition, can we say that A is a subset of itself? Well, all right, so A is a subset of B if every element of A is also an element of B. So it's if every element of the first one is also an element of the second one. Is that true here? Is every element here an element over here? Yep, that's true. A is a subset of A. So a set is also a subset of itself. And that goes for any set. B is a subset of B. C is a subset of C. On and on we could go. All right? Now, let's think about this. What about that one? Is the empty set a subset of A? Is the empty set a subset of A? Well, that was a little trickier. I know that is, but one way to look at it is, you know, here we had C was not a subset of A because we had the element there that disqualified it, if you will, from being a subset. E knocked this out from being a subset of A. Is there any element here that's not an element over here? Is there anything that disqualifies this from being a subset of this? Well, no, there's not any elements to check really. So it's kind of by default. Yeah, I'll do a little example here in just a second that may help a little bit explaining it too. But yeah, the empty set is a subset of A. The empty set is a subset of any set. So it doesn't matter. The empty set's a subset of B, C, and all that. Because there's just not any thing to disqualify it from being a subset. Okay? All right, now, there's also a little thing related to subsets, and that is the proper subset. A is a proper subset of B. Oh, let me make one other little note here. Does this symbol here, subset, does that kind of remind you of that? Sort of looks like the less than or equal to, doesn't it? Well, in a way, that's sort of what we're looking at because notice here, A is a subset of B, so yeah, we've got A, it's less, right? It's less than B, right? So that would be the less than side of this. But we could also have equal, right? So this would be an example of where we have a subset kind of on the equal part of this. So in a way, that sort of does go hand in hand with that less than or equal to. Now again, you don't want to because it's not always, because this one is 2 elements, this one's 3. It's not always that if you have fewer elements, it's a subset, but you hopefully get my idea there. You do kind of have a less than or equal to sort of vibe there. Okay. All right, now, on the proper subset, though, here's what we got. A is a proper subset of B if A is a subset of B and A does not equal B. So there's an extra little restriction there. To be a proper subset, it's a subset, so every element's an element. Every element of A is an element of B, but you've also got A is not equal to B. So it's a proper subset. And the symbol for proper subset is this. You got the, sort of looks like the subset symbol, but what's missing? The line below it, yeah. You don't have the little line below it. So that means it's kind of a specialized deal because, yeah, you got a subset, but it's not equal to B. And notice with our little analogy there, what if this is more in line with the less than, so what's missing there? It's the equal to part, right? The equal to part's missing. And that's what this is saying. So, in a way, what the proper subset is, it has to be a smaller set because it can't be equal to the set. A can't be equal to B. All right? So going with our sets over here in the proper subset, okay, so much the same. Is A a proper subset of B? Yeah. A is a subset, and it's not equal to, so it's a proper subset. C is a proper subset of B, so we could use that proper subset symbol there. We could use either one for those two. Of course, C is still not a proper subset of A. It's not a subset, so it's definitely not a proper subset. But when I get to the ones like this, so A was a subset of A, but is A a proper subset of A? No. Because to be a proper subset, it can't be equal to, this one can't be equal to that one. And they're definitely equal there, for sure. Same letters, okay? So, yeah, the proper subset, like I said, it just kind of takes the equal to part of it out. The empty set is the proper subset of A, yeah, because the empty set obviously doesn't equal A there. So, all right. Now, let's think about. Let's just take a set and let's think about all the different subsets a set could have to kind of think about how many subsets does a set have. It's got a bunch actually, usually. So let's talk about the number of subsets a set has. All right. All right, the way I like to go through this is, let's just think about a particular situation here. Let's say I've started up a, I don't know, a food stand, and all right, I'm serving, let's just say hot dogs, okay? So I've got a hot dog stand, and just starting out, all I can afford is mustard and ketchup. And thinking about my advertising here, how many different types of hot dogs can I serve with those two condiments there? So that basically what I'm thinking of is, how many subsets could I make, right? Well, obviously I could have mustard only. I could have ketchup only. But what else could I have? Plain, which is the empty set, isn't it? Yeah. Doesn't it make sense that I should list the empty set here? Yeah, that's a possibility for this. And so, yeah, hopefully that helps you a little bit. The empty set is a subset, okay, because you could just have nothing. Or, yeah, you could have the mustard and the ketchup. So again, the set itself is a subset. So there's 4 subsets in that case. All right, well, we did pretty good few months. So let's say we're able to add, we got mustard, ketchup, and then, yeah, we could throw in some relish to the mix. All right, so now how many subsets do I have there? We're going to have mustard. I could have ketchup only, relish only. Or I could have 2 at a time, right? Mustard, ketchup. Or I could have mustard, relish. Or I could have ketchup and relish. What else?
None.
None, okay, the empty set. Or
All
all 3. Now, one other thing I mentioned here, what about ketchup mustard? Would that be different? Why is that not different? That's the same as this one, right? Mustard, ketchup. Remember, in sets, the order doesn't matter. So rearranging them is not going to change the set. So this is it. How many I got? 8. Yep. 8 subsets. All right. So I had 8 subsets. All right. Well, we could keep this going. We could bump it up to 4, but if we kind of go back, let's just say I did mustard only, and the subsets there are pretty limited. We could just have mustard, or we could have none. So that's just 2 subsets. So I think that's enough here to establish a pattern. Do you see what's happening? So if I have one item, one element, there's 2 subsets. If I have 2 elements, there's 4 subsets. If I have 3 elements, there's 8. So if I went to 4 elements, we're not going to list them, but if I went to 4, mustard, ketchup, relish, and onions, okay? How many subsets? What's happening? Is it doubling? Doubling each time. Okay. So if I went to 4 elements, yeah, there'd be 16. All right, but there's even a stronger connection here, besides just noticing that it's doubling, right? I went to 2, to 4, to 8. Yeah, it's going to double again to 16. 5 would double to be 32. But there's also, like I said, an even stronger connection here. Notice these numbers here, the 2, the 4, the 8, the 16. They're even numbers, but even more descriptive of those are powers of 2. This is 2 to the first. This is 2 to the second. This is 2 to the third. This is 2 to the fourth. So if I had 10 elements, how many subsets would there be? Well, do you notice here the 1, the power of 2, the power of 3, the power of 4 here, what that matches up with? What does that match up with? 2 elements, 3 elements, 4 elements, 1 element. Yeah, the power of 2 there is the number of elements. So if I have 10 elements, how many subsets? 2 to the 10th? 2 to the 10th subsets. Yeah, it's doubling, so it's getting large quite fast because 2 to the 10th is not 20. What is 2 10th power? 2 to the 10th power? 1,024. There's 1,024 subsets that we could put up here if we had 10 elements. Okay? So here's a formula or note here. Okay. So if a set has n elements, then it will have how many subsets? Well, the number of subsets is always a power of 2, so it's 2 to the nth power. So how many ever elements there are, you go 2 to that power, that's the number of subsets. Okay? Now, be careful because it's real easy to get those backwards, and we're not squaring the number, we're going 2 to that power. Most calculators, it's either 2, for doing the 10, 2 x to the y, 10, or 2, then that button there, instead of the other way around. You do the 2 first and then the power. And that'll get you the right number. Okay. Now, while we've got this up here, let's also notice this other thing. And that is the number of proper subsets. Remember, proper subsets, if I'm just dealing in proper subsets, a proper subset has to be a subset but smaller, right? It can't be equal to. So if I'm doing the proper subsets here of this one, that eliminates the MK, because I can't do the set itself. I can't do equal to. If I do the proper subsets here, that eliminates this one, the MKR. Well, what does that do to my number of proper subsets? Well, the proper subsets just have 3. The proper subsets here would be 7. The proper subsets here would just be 1. And the proper subsets here would be 15. So what happens if I just want the number of proper subsets? It's just 1 less, yeah. The number of proper subsets it's just 1 less than the number of subsets. Yeah, just take 1 away. Just take 1 away. So up here, we've got 10 elements, 1,024 subsets, so how many proper subsets? 1,023. 1,024 subsets, so 1,023 proper subsets. You just subtract 1 from the number of subsets, not the number of elements, but the number of subsets. Okay, so let's do one all the way from scratch here. All right. So if I have A equals, let's just make it easy, I guess. Let's go A, B, K, M, N, P, Q, and Z. Okay. Just kind of a random selection of letters there. How many subsets do I have? Well, how many elements do I have? 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 elements. Well, the number of subsets is always 2 raised to the number of elements power. So the number of subsets would be 2 to the 8. How much is 2 to the 8? Somebody punch it in. Somebody have their calculator handy? 2 to the 8. 2 to the 8. Somebody do that for me.
256.
Say that again?
256.
256. All right. So we're going to have 256 subsets. How many proper subsets? 255, yeah. Yeah, the number of proper subsets is just one less than the number of subsets. So you just subtract 1 from whatever this number is here. So you won't have to list those out. There's just a lot of them, but there's different, just a lot of different sizes and so forth. So that adds up to be a lot. Any questions about that?